amount of water you have in there on a real-time basis. Now, if you have the appropriate high-resolution weather prediction tools, and you know which parts of your cities are going to get flooded more than others, you can combine that with your real-time view, and you can be able to tell exactly how the storm is going to impact your source system. Then, perhaps what you need to do, start preparing. Clearing the streets, preparing the sewer system, clearing it out, pumping the water out of a certain city or another part of the city to absorb the rest of the water, and actually use the existing capacity more efficiently. And so we've started talking to several water utilities about this. They're interested, and it's basically a smarter way. We're not saying you can avoid digging tunnels altogether, but perhaps you can use the existing capacity more efficiently, or dig smaller tunnels, which obviously has a huge impact on reduced construction costs. And what you could deploy is basically a command center, if you will, a control dashboard that allows you to have a real-time view of your sewer system. We have a variety of asset management tools at IBM, and some of our partners have tools that can bring the data in from sensors, so you can really get a real-time view of what's going on, combined with weather. And you can have more data, basically more information about what's happening, as opposed to just those two people that are in your treatment plant that have been there for 40 years, and they know that when it rains this much, they got to close this pipe and they got to overflow here. And so we think there's a way to get all that information that are in people's heads into some of these tools, into some of these analytics, so you can start to be more efficient. Metering is a whole other area. So we know about all the metering in the electric grid space. They are really pioneering the whole smarter metering technology. And that's because energy is getting more expensive, a lot more expensive than water. So perhaps the need is there to give utilities better information about the health of their grid, but also consumers, homeowners, more real-time information about how much energy they're using. So perhaps water is getting there. It's not there yet, but in some places around the world, there is a need to have smart water meters. So your utility can know exactly how much water it needs to supply based on a real-time view of demand. And perhaps your homeowner, who's the leading edge of these homeowners now are the conservative-minded, but ultimately it could be driven by pricing. You can get a better view of how much water you're using. You need to curb some of your water usage on the weekends, or if you see an anomaly in usage, perhaps there's something going on. Perhaps there's a leak, or perhaps there's theft. In some cases, not necessarily here in the U.S., but in other parts of the world, there's actually water theft. It's a huge issue. And so a whole infrastructure around smart metering will help mitigate some of those issues and become more efficient. We actually have a group in Israel. Israel is obviously very concerned with water management. A lot of very innovative technology comes out of Israel just by the very need. Israelis are very entrepreneurial, but they also have a huge issue because they have very little water. So we have in our lab there, we have some analytic tools that they're looking at consumption behaviors. And by modeling different types of groups of homes, we're able to detect anomalies, whether it's high consumption, low consumption, or spikes. And this thing then can be used by the water authority to either send alerts to the appropriate homes or group of homes, or perhaps if it's not as urgent, perhaps there's a different set of services. You want to sell high consumption homes versus low consumption homes. Maybe high consumption homes need some sort of conservative type services, fridge magnets that tell them how much water they're using. Perhaps the low consumption homes can have some sort of rebates. To just kind of incent that conservative behavior. And then perhaps the spike is something that is more of an anomaly that generates some sort of work order to figure out exactly what's going on. So this is the type of data now. If you have this data in real time, you can start doing these services. Let me just go through a couple of other examples here. I mentioned briefly smarter levees. We have a group